Throughout history, humans have always told each other stories about the gods in the sky, of mysterious spacecraft and the cosmic secrets still being kept. But today, we will explore a completely new story together. A story is not merely a figment of imagination, but also conceals scientific principles, where the boundary between reality and dreams is magically blended. That is the story of Element 115, a small but crucial piece holding immense potential within the periodic table. It is considered the key that unlocks the door to anti-gravity, antimatter, and perhaps even the future of humanity. I still remember vividly the first time I heard about Element 115, the name Moscovium. While sitting in front of the computer, I was browsing through science websites to see if there was anything interesting today. And suddenly, a strange idea struck. A scientific element that could make objects levitate, defying Earth's gravity. This idea sounds more like a plot point lifted from a science fiction novel or an episode of Star Trek than something that actually exists in a laboratory. However, when I delved deeper, I realized that Element 115 was not merely a fictional element. It was successfully synthesized, an achievement accomplished by scientists. And currently, this issue is igniting fervent debates within the global scientific community. Today, I would like to invite you to join me on this journey of discovery, where we can both learn and let our imaginations soar. And together we pose the question: could Element 115 indeed be the bridge connecting Earth to other worlds? The emergence of a peculiar element. Let's turn back time to the year 2003, in a small Russian town called Dopna, where scientists in white lab coats work diligently amidst laboratories filled with modern equipment. This is where Element 115 first appeared in the world, not brought here by a meteorite that fell from space, and from human hands, through an immensely ambitious experiment. Russian scientists, together with their American colleagues from the Lawrence Livermore National Laboratory. Scientists used a machine called a particle accelerator to bombard americium-243 atoms with carbon-48 nuclei. As a result, a few atoms of element 115 were created, but they only existed for about 0.65 seconds before decaying into smaller fragments. They named the element Moscovium to honor the Moscow region where the experiment was conducted. It is a superheavy element, belonging to the group of high-mass elements on the periodic table, with 115 protons and approximately 175 neutrons composing its tiny nucleus. All are squeezed together into a space a million times smaller than the width of a human hair. And this very oppression made it extremely unstable, quickly collapsing like a sandcastle before the sea waves. But that wasn't the end of it. While scientists in Dubnon were celebrating their achievement, a bold idea began to spread beyond the laboratory. Could Moscovium be capable of far more than what we currently know? Could this be a special element, one that exists not merely to break every record in the periodic table? And it even brings the power to change how we understand the universe. Now, let us envision a wondrous scene, a massive, colossal object. It could be a rock or a car, suddenly hovering in the air without any need for an engine or propellers. That is the dream of anti-gravity, of the ability to counteract the Earth's gravitational pull. Gravity is precisely what has kept us firmly on the ground since the dawn of humanity. For decades, this idea remained pure science fiction. But then, Element 115 appeared, carrying with it a deeply alluring whisper. Could that be the key to turning that dream into reality? The story of Moscow's anti-gravity device does not begin with the scientists at Dopna. From a highly controversial figure, Bob Lazar. In the late 1980s, Lazar, who claimed to be a physicist formerly employed at Area 51. Based on classified American military documents, he claimed to have witnessed the incident. Extraterrestrial spacecraft use element 115 as fuel. According to Lazar, the element 115 he had known was completely different from the noisy version synthesized by scientists later. He stated that it is an ultra-stable isotope capable of generating an extremely powerful anti-gravity field. It is powerful enough to lift these colossal machines into the sky and carry them across the vast distances between the stars. Of course, Lazar's story still has many dubious points and lacks any verified scientific evidence. And this hypothesis is not recognized by the mainstream scientific community. But interestingly, when Moskva was synthesized in 2003, it reignited the never-ending debates. Could there exist a more stable form of element 115 that humanity has not yet discovered? And even if it does exist, can it truly perform the miracles that Lazar described? To answer this question, we must venture into the profound depths of theoretical physics. Some scientists have proposed a rather simple thought experiment. Imagine testing the anti-gravity properties of element 115 by placing a heavy object on top of it. And then observe whether that object can fly or not. This idea is built upon the assumption of Moscovium's specific nuclear structure. The arrangement of protons and neutrons within it can generate a peculiar energy field, defying gravity. In quantum mechanics, these particular energy states can interact with the surrounding space in ways we cannot yet fully explain. Just as a subwoofer can make an entire room vibrate. But the problem is, the version of Moscovium we currently know is incapable of doing that. With a half-life of a mere 6 seconds, it decays before you can even utter a word, a true anti-gravity phenomenon. Therefore, if the dream of element 115 having anti-gravity capabilities were real, we must find an isotope with greater stability, a hidden gem somewhere in the vast universe. Or a feat that future scientists might achieve. If you thought anti-gravity was astonishing, then get ready for an even stranger concept: antimatter. In the world of science, antimatter is likened to a mirror image of ordinary matter. Every proton, electron, and neutron has a corresponding antiparticle, considered to be its twin. These antiparticles have the same mass but carry the opposite electric charge. When matter and antimatter meet, they annihilate each other and release a tremendous amount of energy in a brilliant explosion, unleashing a force more powerful than any nuclear bomb ever created by mankind. Recently, some scientists have begun to raise the question: could element 115 have any connection to antimatter? This idea stems from the assumption that Moscovium possesses a unique nuclear structure. Antimatter particles can be created or interacted with under specific conditions. If this is true, it would explain why element 115 has the ability to produce an anti-gravity effect. Energy from antimatter has the capability to bend space-time in a manner that conventional gravity cannot achieve. But as with every other great scientific story, there always remains a great unknown. Currently, there is no evidence proving that Moscovium is related to antimatter. At CERN, scientists conduct experiments to create and study antimatter. Element 115 has never been mentioned as